is number e? To find out, we will define a sequence of numbers, which is bracket 1 plus 1 over n at the power of n. This sequence of number is defined for every natural positive number. We will do the expansion of this binomial as we know it. So an is 1 plus n choose 1 times 1 over n plus n choose 2 times 1 over n squared, and so on till the last term, which is n choose n times 1 over n at the power of n. We now substitute with the definition of choose, which is 1 plus n over 1 times 1 over n plus n times n minus 1 over 2 factorial times 1 over n squared plus the last one, n times n minus 1 times n minus 2 times 2 times 1 over n factorial times 1 over n at the power of n. Now, let's see how we can calculate every term. The second one is easy. See, we can cancel out n and it will stay 1. Let's look at the third one. Beside 1 over 2 factorials, we have n times n minus 1 over n squared, which is, we can cancel out one n, and then we will get n minus 1 over n, which is 1 minus 1 over n. We can try out what happens with the fourth one. The fourth one is, beside 1 over 3 factorial, we will have n minus 1 times n minus 2 over n at the power of 3. We can cancel out one n, and then we will have n minus 1 over n times n minus 2 over n, which is 1 minus 1 over n times 1 minus 2 over n. In the same way, we can write all the terms. Let's continue calculating an. An will be 1 plus 1 plus 1 over 2 factorial times 1 minus 1 over n plus 1 over 3 factorial times 1 minus 1 over n times 1 minus 2 over n plus, and so on till the last term, which is 1 over n factorial times 1 minus 1 over n times 1 minus 2 over n times 1 minus n minus 1 over n. And this is our expression we should use further when substituting n by n plus 1. You can see this expression is available, is true for all n positive natural. Let's go and do this. So, for n substitute by n plus 1, we will get the next term, an plus 1, will be 1 plus 1 plus 1 over 2 factorial times 1 minus 1 over n plus 1, and so on till 1 over n plus 1 factorial times 1 minus 1 over n plus 1 times 1 minus 2 over n plus 1 times 1 minus n over n plus 1. If you count terms in the expression for an, you will see that you will have n plus 1 terms. In the expression for an plus 1, we will get n plus 2 terms. Let's now compare term by term an and an plus 1. After the second term, so we can see first and second terms are the same in both expressions, we will see that 1 over 2 factorial times 1 minus 1 over n is smaller than the third term in an plus 1, which is 1 over 2 factorial times 1 minus 1 over n plus 1. Please check by yourself. This is a true fact. So, comparing all the terms between these two expressions and also considering the fact that an plus 1 has another term which is for sure a positive one, we can easily say that for every n positive natural, we will have term an will be smaller than term an plus 1, which means that an is an increasing sequence of numbers. This means also that for all n, an will be greater than or equal to the first term, which you will see it is 2. We will keep in mind this result and go further. Let's see now what happens at the other end of this sequence. We use this expression for an and write. Also looking at term by term, we can write that an it's not equal but less than 1 plus 1 plus 1 over 2 factorial, because this third term in an is less than 1 over 2 factorial. The same we will write further. So 1 plus 3 factorial plus 1 over n factorial. We go further and write this. Every term we see on the left side of the inequality will be less than or equal in the case of the first 3 terms. So 1 plus 1 plus 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, and so on till the last term, which is less than 1 over n minus 1 times n. Now, we will use another result which is very useful in sequences and series, which says that 1 over k times k plus 1 is equal to 1 over k minus 1 over k plus 1. Also, please check by yourself. This is true for all positive natural numbers. We go now back and write further that this sum will be, in this case, equal then 1 plus 1 plus 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3, and so on till the last term, which is 1 over n minus 1 over n. We can see that we can cancel out a lot of terms. This with this, with this, with this. And we will get the result 3 minus 1 over n, which is easily seen and demonstrated that this number is less than 3, which means our sequence of numbers will be also less than 3 for every natural positive number. That's why combining our first result, which is an is greater or equal to 2 and less than 3, tells us that this sequence of number is a sequence which has two exact limits, 2 and 3. This means that using one of very important theorem demonstrated by Weierstrass, that the sequence of number an is a convergent one. So, because of this fact, we can say that it exists a limit of this sequence, which we denoted by E. So E is the limit of this convergent sequence of numbers, and because we know that all the terms of this sequence are between 2 and 3, of course E will be also a number between 2 and 3. This is E, which is an irrational number, and this is another demonstration we are not planning to do here. So remember, E is defined as the limit of a sequence of number which looks like this: 1 plus 1 over n bracket at the power of n. This is E. Goodbye.